linear equations. And what a system of linear equations is, it's two linear equations, and you will find an answer that fits into both of them. And we're going to use this in a lot of practical situations. The practical situations that you could have would be supply and demand in the business world. You could also look at your profits versus your expenses. So there's a lot of different ways to look at systems in the real world. And what you're looking for is where the two lines cross. We're going to have three different ways of solving systems. The first way is going to be graphing. Second way is going to be called substitution. And the third way is going to be called linear combinations or elimination. We're going to start off with graphing. In all three cases, you can check your answer to see if it makes it true. So to check to see if a system, we're going to check to see if the point 3, -3, all right, solves this system. So we're going to check what we call the intersection, where the two lines cross. We're going to check the intersection. And just like we had done in the previous parts, checking solutions, you're going to substitute 3, -3 into both solutions. So let's take a look. First, let's take the first equation, and we're going to say a -3 is equal to 3, right, times 3. We'll substitute in our x, minus 12. Now for this 3, -3 to be a solution, it has to make both of these true. All right, so we have -3 is equal to 9 minus 12, and therefore -3 is equal to a -3. So the first solution, 3, -3, works for the first equation, linear equation. The second linear equation, let's substitute in, again, -3 is equal to a -2 times 3, all right, plus 3. And we end up with here, we get -3 is equal to a -6 plus 3. And again, we get -3 is equal to -3. So both linear equations work for 3, -3. So it is the solution. It is where these two lines would cross on your graph. System by graphing. We need to graph both of these lines. We're going to put both of the lines into slope-intercept form. So on the first side, we're going to take a -3x to both sides of the equation, and we end up with the equation for the line of y is equal to -3x, right, plus 11. So we will graph y is equal to a -3x plus 11 and see where these two lines cross. On the other side, we have to solve this one for y, put it into our slope-intercept form. So we're going to subtract x, and we get a -2y is equal to a -x, right, plus 6. We have to divide by a -2. Right. And the equation for this line is y is equal to 1/2 x minus 3. So we are going to graph both of these lines and see where they cross. All right, we are going to graph the system. Y is equal to -3x plus 11, and y is equal to 1/2 x minus 3. Now, first thing we'll do is we will graph -3x plus 11. So we find our y-intercept at 11, and we put a dot. Our slope is a -3 over 1, so we're down 3 over 1, down 3 over 1. So there's our first graph. Y is equal to -3x plus 11 is our first line. Now you want to be as accurate as possible when you're graphing these lines, because the solution is going to be where they cross. Right, and graphing is most effective when they cross at, major points like 1, 1, 2, 2, 4, 5, whatever. Graph the other line, our y-intercept is a -3. So we go down here to -3, we put a dot. All right, our slope is 1 over 2, so we go up 1 over 2, up 1 over 2, and right there is our solution. All right, so what we think is our solution, so let's graph the second line. All right, and find out where they cross. All right, they cross at 4, -1. So that's what we think is our solution. Now let's go and check it on the board in both of these equations. So when I substitute -1 is equal to a -3 times a -4 plus 11, I end up getting a -1 is equal to, all right, -12 plus 11, so therefore -1 is equal to -1. All right, so we get a -1 is equal to a -1. In the other one, we have a -1 is equal to 1/2 times 4 minus 3. So we get a -1 is equal to 2 minus 3. And therefore we get a -1 is equal to a -1.